Have you ever stopped to think about how all the different apps on your phone just talk to servers that could be thousands of miles away? It feels seamless, almost like magic. Well, a huge part of that magic comes down to this really powerful idea called remote procedure calls, or RPCs for short. And today, we're going to pull back the curtain and see exactly how this fundamental piece of modern software really works. But to really get why RPCs are such a big deal, we first have to understand the problem they solve. And trust me, it's a headache that developers have been dealing with for decades. The absolute nightmare of writing network code. Does this sound familiar to any of you developers out there? You're building a cool, complex system, but you keep finding yourself writing the exact same networking logic again and again and again, just to get your different services to talk to each other. It's like you're stuck in a loop, right? Yeah, these headaches are pretty much universal. For every new service, you're wrestling with a different HTTP library, whether it's in Go or Java or Python. You're manually coding for when things go wrong, building retry logic from the ground up. You're writing all this tedious boilerplate code just to turn your data into JSON and then back again. And that's all before you even get to think about optimizations like compression or streaming. It's just a ton of repetitive, error-prone work that gets in the way of what you actually want to be building. Okay, but what if we could make all that complexity just disappear? What if calling a service on another continent felt just as simple as calling a function right there in your own code? Well, that is the promise of remote procedure calls. And here's the difference, plain and simple. On the left, you see all the ceremony of a manual network call. You're setting up clients, defining headers, serializing your data. It's a whole process. But look at the right. With RPC, it's just one single clean line of code. All that complex networking stuff, it's still happening, don't get me wrong, but it's working for you, behind the scenes, completely out of sight. So what exactly is an RPC? Well, think of it as a protocol that lets your program run a function on a totally different machine as if it were right there, locally. It handles all the messy network plumbing so you can stop worrying about infrastructure and just focus on building your features. Okay, so how does this magic actually work? I mean, something has to be doing all that heavy lifting, right? The secret lies in this really clever component called the stub. It's kind of the unsung hero that makes all of this seamless communication possible. The best way to think about a stub is like a universal translator, almost like something out of science fiction. Let's say your client is speaking Python, but your server only understands Java. Well, the stub acts as the interpreter right in the middle, making sure they can communicate perfectly without you having to write a single line of translation code. It's amazing. So here's the play-by-play. It all starts when your code makes that super simple function call. The client stub immediately intercepts it. Then it does something called marshalling, which is just a fancy word for packaging up your data into a format that's easy to send over the network. Think of it like putting a gift in a box, ready for shipping. Once it's sent, the server stub receives it and does the reverse, unmarshalling the data back into a native object the server can actually understand. It's this perfect, seamless round trip, and it's all handled for you. And this is where the real power shines through. A stub can take a complex data structure in Go called a struct and automatically convert it into a Java class on the server side. This kind of seamless multi-language communication is an absolute game changer, especially for building modern microservices. All right, so we've covered the how. Now let's get to the fun part, the why. What are the real-world payoffs you get from using RPCs? The biggest win, without a doubt, is a massive boost in developer productivity. I mean, when remote calls feel just like local ones, developers can move so much faster. All those boring, mundane tasks like handling failures and converting data, they're handled automatically. And get this, instead of writing client libraries by hand, RPC frameworks can actually generate them for you, which creates these strong, reliable contracts between all your services. But it's not just about making developers happy. It's also about raw performance. Modern RPC frameworks like gRPC are just built for speed. They have efficient data compression built right in. They use modern protocols like HTTP/2, which allows for multiplexing. That's basically sending multiple requests over a single connection, kind of like having multiple conversations on one phone line. All of this adds up to way faster, more efficient communication between your services. But hey, let's be real. No technology is perfect. No silver bullets here. So to get the full picture, we really need to talk about the trade-offs. What are the potential gotchas you need to watch out for when you're working with RPCs? So the biggest thing to keep in mind is that auto-generated stub. If you change a function, even a little bit, you have to regenerate the stub. If you forget, things will break. Testing can also be a bit more complex than with a simple REST API. Honestly, there's just a steeper learning curve to get started, and for some frameworks like gRPC, you might need an extra layer just to get full browser support. Which really brings us to the final question, doesn't it? When you're building really complex systems, are these trade-offs just a small price to pay for that massive boost in productivity and performance? Well, the answer is really going to depend on your project, but now you have the tools to help you make that decision. Thanks for tuning in.